Yeah.
I record this. What benefits do they provide? The importance. What is the fundamental architecture, which is behind blockchains? What are blocks? What are nodes? How does consensus arrived at? How do they do security? What are utilities and use cases? Private blockchains, asset tracking, finances, marketplace, and then we're going to look at Ethereum. So your job right now is just to learn. You're getting paid. You have hours on the clock just to learn as much as you can. So take this. It's a good professional development opportunity. Hopefully, by the end of not just this project, but the end of the next 2 weeks, you'll be able to be very confident that you know a lot about blockchain and Ethereum and NFTs, and not just for this project. You know that will just be good for your career in general.
Yeah. That's fun. Yeah.
So, what exactly is a blockchain? A blockchain is a kind of transaction recording technology. That's what it's for. It's designed to record changes and balances, people setting things and transactions. So, a blockchain is a chain of blocks. So, what's a block? A block is just a list or a collection of transactions. That's all it is. When you put it together, it becomes a distributed database or a decentralized ledger. So it's a database where each entry is this person sent this much of this token to another person. It's a database which just has entries like that. And then it's limited to a certain amount of entries before it becomes a block, and then they're put together historically. So blockchains have three major components now.
So each block will have like certain amount of entries.
Yes.
Then okay.
Exactly. Yep. Each block will have a certain amount that is capped for a couple of reasons. One of the reasons, sorry, let me close that real quick so you don't have to hear a whole bunch of beeping. So each block, hey Jim.
Hello, Jim.
Hey guys, sorry about that.
No, you're fine. You're fine. I recorded. You didn't really miss too much. We were just talking about Pradeep about where we're going, and then we just did like the introduction side.
Okay.
So each block is capped to how many transactions you can put on it, and there's a couple of reasons for that. Number one, not everybody wants all of the transactions over all of the period of time. What if we're in the year 2200 and there's been billions of transactions? Maybe you only want the transactions for the last year. So if it's not cut up in blocks, then you would have to get all of it. Another reason is that you have to have a finite amount so that you can verify transactions in batches to make sure that they're valid, if that makes sense.
Yeah.
Okay. And so it's a ledger which is decentralized essentially. So it does transaction storage, data immutability, and cryptography. So the whole purpose of the blockchain, of any blockchain, is to store transactions. It's just a database or a ledger which is keeping track of people sending stuff to other people. And it can also store transactions which are occurring right on the blockchain, native transactions, or transactions which are happening somewhere else. And it would store transactions which are happening somewhere else by getting information about those transactions and then keeping it on the blockchain. What kind of transactions can it be, or what kind of things can be sent? It could be physical things, it could be real things, or it could be virtual things. And we'll talk more about that. The next thing is that, okay, so you have this ledger, which is decentralized. You have this database, which is keeping track of stuff. How do we make sure that it's not being tampered with, it's not being falsified, it's not being changed? There's something called data immutability. And basically, the main component is something called consensus. All blockchains need to have some kind of a consensus. So consensus is done in a couple ways. One of the main ways is a consensus algorithm. So we'll get more into that. But the main idea of consensus is that nothing on the blockchain can be changed. That all of the people that are on the network agree that all the information is valid. And then there's also something called miners, which we'll talk about. It's relevant to Bitcoin. It's not too relevant to this project, but we will touch on it. The next thing is cryptography. All blockchains are peer-to-peer, and they involve cryptographic algorithms. Do you have any questions about this?
No, I don't have.
And you can interrupt me at any point if you have like a question that pops into your mind. That's fine.
Yeah, I think like I have about the peer-to-peer, but when we go through this documentation, maybe later I will have an answer for that one. If not, I'll ask that question later.
Do you have a question about lib P2P specifically, or just P2P networking?
Just the P2P networking
Okay.
means like yeah, if it is just a peer-to-peer, so how it collects like so for example, like if we have to pull a record from the database, like we know where to get the data, right? But in the peer-to-peer, how we know like where to get the data, what we are requesting?
So that's actually a really good question.
Okay.
And there's a couple ways to solve that. And lib P2P is one of the ways to solve it. So when we will talk more about networking and blockchains a little bit later. So that's a very good question. We'll come back to it.
Sure. Yeah.
Okay. But it shows to me that you're thinking about these things and you are understanding them, because that is a very natural question to have. Okay. So a database is a kind of file system. We all know that. It organizes data, which is collected, and it's stored. You access it electronically. But traditional databases are usually centralized, meaning that the database is on one device or a couple of devices. It's normally owned by one person, like an Excel spreadsheet, or a company. For example, a bank. A bank has many databases that contain different kinds of information pertaining to people that use that bank. And one of the issues with that is that once you send data to a database that somebody else owns, you no longer have any control of that data. Whether that's your money, which you deposit in a bank and it becomes numbers, or your personal information, whatever it is, you no longer have any control over. So one of the ways to get around that, how do we make sure that we still have control over our own data? How do we do that? One of the ways to do it is to get rid of the centralization. If the database is no longer centralized, if no one person owns the database, then you have your own sovereignty and control over the data. So that's kind of where the idea of decentralized databases come from. The information is not concentrated. The information is held by many different clients. And it solves this issue of you not having control over your data anymore, because the information is controlled by the group or the hive. So going back to your question that you just asked, sometimes on blockchains, everybody has all the information that you need. Sometimes only some people have the information that you need. And so there has to be a way, if everybody has the information, you can just connect with anybody. It doesn't matter. If only a specific person has it, or specific people have a kind of data that you need, then it becomes more complicated. And so we'll get to that when we get to networking.
Oh.
So a long time ago in the past, whenever people had transactions, they recorded them in ledger books. So they had these big books. When you walked into the bank or you walked into the guy who was loaning you his office, they had a big book, and they used to write who gave what money, who saved what, who borrowed what, so on and so forth. And whenever they would write in that, that's a transaction. Jim borrowed $500 from the bank. They would write that in the book. Whenever they finished on a page in the book, then the whole page became filled. And then they might put a signature at the bottom of the page that somebody verified that there was no fraud going on. And then they would flip to another page and then start writing new transactions to it until they fill that up. And then when they ran out of pages, it became a book, a complete ledger book. So a blockchain is basically the same exact idea.
Okay.
Each transaction is a ledger in the block. Each transaction is recorded in the blockchain. A full page of transactions is a block, and then when you have all of these blocks together, it makes a blockchain. So they record transactions. Every transaction is recorded, but it doesn't necessarily have to be transactions just with money. You could trade software. You could trade physical objects and just record the trade on the blockchain. You could trade something which is a virtual object, but you have something on the blockchain representing its value. Or you could just trade numbers, which have value just because you believe in the technology, like Bitcoin, or even contracts. You could buy and sell contracts, or contracts which are software, which we'll get into all of that. So when the transactions are collected, the pages are called blocks. When a page is full, it's added to the ledger, and that's called a block being committed to the chain. Do you have any questions about anything here?
No, this is very clear.
Great. Are you familiar with this stuff? Is some of this new? Does this help?
Like very little bit, not the way like a not a very clear way. So I'm able to like relate what I know and what it is actually.
Okay, good. So what makes blockchains different than just regular technology? So this is our client Dapper. This is one of their what's it called? Browser add-ons
Okay.
for a wallet. So what makes it different is that the transaction becomes decentralized. You don't have to trust Dapper or Bitcoin, some guy who owns Bitcoin technology, or any company. You're trusting the technology, which is not biased. There's no person controlling it. And you're trusting the fact that it's stored on thousands, if not tens of thousands, if not hundreds of thousands of computers. And not only is it stored on a whole bunch of computers, it's stored on those computers over a very wide area all across the world. So if Russia decides to blow Ukraine off of the map, well, that's not going to affect the Bitcoin network at all, because all of the nodes are spread not just in Ukraine, but all across the world. Consensus algorithms. This is another thing which distinguishes blockchains. Yes, go ahead.
Yeah. If it is like stored in, for example, like thousands of computers, so how the data will get synced, and for the data sync, it will take like more time, kind of thing, right? So how it will be like efficient compared to the actual database?
So data syncing
Mm.
and efficiency is dealt with in consensus. So they had to come up with a good way to, so you have all these computers everywhere and they're all updating this database. How do you make sure that the copies are consistent and that it goes quickly, so on and so forth? That's what they use consensus algorithms for. So we will talk more about consensus algorithms, but that is the solution, and it's an effective solution. Ethereum is almost instant. Bitcoin is a little bit slower now, but it only takes a couple minutes, and it's instantly sending stuff across the world. So it has been solved. That's a great question, and that's why it's the next bullet point. So it seems like you're following along very well, which is good. So because of consensus algorithms, yes, go ahead.
Yeah, and also like this thousands of computers means like it's a user computer or like a data center kind of thing.
So it depends on the particular blockchain technology that we're talking about, whether or not it would have to be like a data center server or it would be like a individual user client computer. So with Bitcoin originally back in like 2010, anybody could just do it on their home client computer and participate effectively. Because of the way that Bitcoin works, now you're going to need a very powerful computer or like a business client. That being said, it's on a case-by-case basis. Anybody hypothetically should be able to interact with any public blockchain, but their level of interaction will be different depending on the blockchain and then depending on a number of other factors, which we'll get into. So there's no one answer to that. It's a
Okay.
case by case basis.
Oh.
So with consensus makes it really difficult to hack blockchains because the way that consensus works in consensus algorithms. And the more complex ones are basically impossible to hack. Another thing is that blockchains allow for confidentiality because of encryption, redundancy, disaster recovery, verification, and auditability. Any other questions? You have a lot of really good questions, and they're right along the technical perspective. So
Mhm.
I think this is going to make sense to you by the end of this presentation.
Okay, sure.
Any other questions?
No, that's it. I don't have anything.
Good. Jim, you can butt in at any time, whenever you feel like.
Good.
Okay. So what are the benefits and importance of blockchain? Why not just put something on the cloud, put a database in the cloud, or just use MySQL or something? One of the reasons you don't have to trust a cloud provider or the database hosting. Another thing is you don't have to worry about any kind of editing or manipulation or the instance going down. Another thing is you can't be audited by anybody who's outside of you. A blockchain can't be audited. You can run your own audit as pertains to your data, but there's no one who can come from the outside and institute some kind of control over a public blockchain and audit it. Do you have a question?
Means like nobody else can audit?
So anybody
Okay.
can look at the open source. If it's an open source blockchain, anybody can look at the data, but nobody will have any ability to change or manipulate or institute any kind of force on the data. But you yourself can check and make sure that all the transactions are valid for your own purposes.
Okay.
So why not use a payment processor or a bank? One reason is transaction fees. Transaction fees are very low on blockchains. Immutability can't be changed. High availability, security, faster transactions. There's no verification or clearing process. You can just make an account, and you don't have to use any ID or anything. And you have total control over your assets. Questions?
No.
Okay, great. Oops, whoa. Okay, so that was the fundamental basics. So now we're going to start talking about architecture and more technical stuff. So we're going to talk about why is this thing like that?
Actually, we can minimize that one. I minimized it.
You want to go back?
No, we can minimize this thing, that pop-up. Yeah.
Okay. I don't know. I'm on Linux, so I think you see like a black box floating around.
Correct.
Yeah, I'm sorry.
But yeah, like there are like 4 options which you can use to minimize it.
Yeah, I'm gonna have this little box just so I can see you, but hopefully it's not too disturbing. So we're gonna talk about blocks, nodes, consensus, networking, and security. So the first thing we're gonna talk about is a transaction. What does a transaction actually look like on a blockchain? So a transaction on a blockchain is a ledger entry, is a database entry. And it's a database entry in the form of a cryptographically signed message. So it has to be signed with some kind of cryptographic algorithm. It's produced, distributed, and then registered on a blockchain. So in a blockchain, anytime you update the database, that's a purchase or a sell. Simply speaking, there's more complicated things, but just for now, it's a purchase or a sell. And it has to come out from an external client. The blockchain is not going to update itself with transactions. Someone has to say, hey, this happened, and send it to a blockchain for it to be registered. So the client or a user sends data to a blockchain regarding a transaction that they want to do. So for that transaction to be accepted, it has to be accepted into the network, has to be put onto a block. The nodes have to agree that it's valid. If any software is involved, it has to be executed, and then it has to be verified. Accepted, collected, validated, executed, and verified. There's a very specific reason that I explained it in this fashion. So do you understand that?
Yeah. So for example, like if like more than one is requesting for, like to buy something, so that request has to be accepted first and then put it on the block. Um,
Validated.
yeah, and then like where this agreed or something will the agreed is between the seller and the buyer kind of thing, whoever sells the thing.
So it actually happens in the opposite way. So it wouldn't be like a request to buy. It would be, I want to send this person X amount of money. So I
Mhm,
try to send that into the network. The network will collect it and determine, okay,
mhm,
is this a valid request? Does this person really have the public and the private key for the account
mhm,
they want to send the money from? Are they really trying to send it to a valid other account? Okay, yeah, everything checks out. Then once it's accepted, then it gets put onto a block. It's collected. Then
oh,
once it's collected, it'll be validated. Okay, all of these transactions, these are all good transactions. Let's make a block. If there's execution that needs to be done, then there's execution, and then it'll be verified and committed to the blockchain.
okay. So to verify these transactions or execute these ones, those are called the miners, or it's a different one.
In Bitcoin, it's called mining. Yes, but that
Okay.
for now that only applies to Bitcoin blockchains. So we will
Okay.
talk about it, but it's not relevant to this project.
Mhm. Got it.
Other blockchains use different solutions.
Okay. But
So each
whoever like doing this one, it is kind of a software like they used and they will get paid. So that is where the transaction fees will go.
yes, so that's where a transaction for Bitcoin, yes, that's how it
Okay.
works. In
Okay.
other blockchains, it works a little bit differently.
Okay.
But in Bitcoin, the miners they do accepting, collecting, validating, and verifying. And in
Mhm.
return for that, there's transaction fees.
Okay.
So each transaction consists of actually sorry, I misspoke. There's no transaction fees in Bitcoin. There's transaction fees in Ethereum because they work differently. What happens in
Mhm.
Bitcoin is they get a portion of unmined Bitcoin, which we'll talk about it. In Ethereum, you get gas fees, which are transaction fees. But
Mhm.
we'll get to that. We'll get there.
Okay.
Each transaction has a date, a time, an
Mhm.
amount, the kind of thing that you're sending, the people that are involved, and then a little bit of code which identifies that transaction, and it's a hash.
Mhm.
So what happens is they put it through SHA-256, and they have a hash of the previous block header, which is just a little bit of data, and it crunches the data, and so it identifies this transaction uniquely. So this acts as a signature, and when it's all put together, you end up getting a particular signature for each block, which is then guessed by miners in order to solve it. But we'll come back to that later.
Mhm.
Questions?
No,
Okay.
I'm good.
So what exactly is in a block? It's a compilation of transactions. It's the best hits of what's going on in the network. So what's in a block is just a list of transactions and any relevant data about the transactions. You can think of it like metadata pertaining to the transactions.
Mhm.
It's important information for the network to function properly, and this is stored directly on the blockchain. It could even store the currencies which are used. So, for example, Bitcoin is stored directly on the Bitcoin blockchain. You could store whatever you're using in the transactions on the blockchain, or you could store it somewhere else, depending on the situation. But generally, most blockchains have very limited storage for obvious reasons, because if thousands of people are downloading the entire blockchain, you don't want it to be petabytes large. So you may limit the size of the transactions and therefore the size of the currency that can be sent on there. And if that's the case, then you have to use storage elsewhere. So how do blocks behave? They permanently record data. What's in a block is there forever. And blocks always consist of new transactions which haven't been recorded yet. And once it's made into a block, you can't delete it or change it. The first block for any blockchain is always called a genesis block. And it has a starting balance if there's a native cryptocurrency with a balance on it. And it serves as the prototype for all the other blocks to follow. Questions?
Yeah, I'm good.
So what do blocks actually consist of? What's actually in a block? Blocks are made when you have the content, the signature, and the nonce of the previous block. So what is a nonce? A nonce stands for number only once, and it's only used for one occasion. So what is a nonce? Basically, a nonce is just a random number, but you can only use it once to identify something in cryptography.
Mhm.
So what they do, what blockchains do, or at least what Bitcoin does. Bitcoin does is it has a complicated hashed number, which is at the beginning of every block. And these people called miners, what they do is they use their computation power to brute force guess what is that number. Whoever when you try to guess that number, what happens is your computer is also collecting transactions, validating them, organizing them into blocks, so on and so forth. When that number is guessed, then you get a portion of Bitcoin, which has never been created yet. So the blockchain itself will say, hey, we're going to create one Bitcoin now, and this Bitcoin never existed before, and we're going to give it to the people that figured out this nonce. And so that's the reward for validating transactions. Now, eventually, Bitcoin will run out. There will be no more Bitcoin. It will limit itself. It's like in 2,140 or something. And the goal is by that time, Bitcoin should be such a big international financial system that nobody needs a reward to do it. There will be like large institutions which have a vested interest, or governments in keeping the blockchain up. But not every blockchain has miners. Not every blockchain has a limited amount of currency. Not every blockchain issues rewards like that. That's all just specifically Bitcoin. But there's nonces on most of them just for identification purposes and for falsification purposes.
Mhm.
So these headers, you put the headers together and it creates a chain. So you have the block hash. The block hash identifies that individual block. And you get the block header, you hash it 2 times with SHA-256, and it creates the block hash. The header itself has metadata in it, and it has 6 items which can't exceed more than 80 bytes, which is the version of that blockchain, the hash of the previous block, the hash of the Merkle root. We'll talk about Merkle roots, but basically Merkle root just summarizes the entire way that the data is structured throughout the blockchain. The timestamp of when it's solved, the bits, and then nonce, the nonce that we talked about. So basically, what a block is just a long list of transactions: sender, receiver, and amount. And it also has information, metadata about the size of the block and the number of bytes from the beginning of the block to the end, and an amount, the count of how many transactions are on it, the previous block hash, and then the block height. Block height means the amount of old blocks by the time you get to this one. So that's how you know your data is up to date, is you ping all the nodes that you can, and whoever has the most blocks, let me see, has the most up-to-date data. Question.
Yeah, actually, like I initially was thinking like who will get the chance to validate the transaction. So we explained that using the nonce, like whoever guesses the nonce will get a chance to validate the transaction, and they will get that transaction fee, right?
And just keep in mind, other blockchains do it differently. That's for
Yeah, got it, got it.
Okay.
But somehow they will get this fee for validating the transaction, right?
Yeah,
Like one
somehow
or the other.
somehow you will get some kind of reward.
Mm.
Somehow, somewhere or the other.
Yeah.
So what is actually traded on a blockchains? There's three kinds of things: digital assets, cryptocurrencies, and NFTs.
Mm.
So a digital asset is a physical thing that you're just representing virtually. So actually, it doesn't have to be physical. It could be a physical object, a virtual object, software, or agreements. For cryptocurrencies, I think we know what these are. They're just digital tokens, they're numbers, they're entries. They have no worth outside of themselves on the blockchain. They're just a medium of exchange stored on the blockchain. They're only electronic. There's two kinds of major cryptocurrencies: altcoins and tokens. Altcoins are just different kinds of Bitcoin, basically. Pure coin, Litecoin, Dogecoin. They work exactly the same. Then there's tokens. Tokens are actually unique cryptocurrencies that live on a different blockchain, which is not directly related to Bitcoin, like Ethereum, Ripple, Next, and others. Then you have NFTs. So NFT it comes from two words: token and fungible. What is a token? A token is just something which represent a value or an event or something. So like a souvenir or like casino chips. If you go to a casino, the chips represent money, or airline miles, or Reddit karma, or items in a video game, or loyalty points, or stocks. Stocks in the company represent ownership of a particular amount of the company. So they represent something else. Fungibility, fungible, this word, it means that you can trade something for something else and they have equal value. So if I give you a $5 bill, and then or if I give you a $10 bill and I say, hey, give me two $5 bills, they're worth the same thing. Or if I have a $10 bill and I ask you to trade me for a $10 bill, then no value was exchanged. They're worth the same thing. But if I have my daughter's art project from kindergarten and you have the Mona Lisa, they might be the same size, even use the same kind of paint, but the Mona Lisa is going to be worth way more than some little girl's drawings. So that's not fungible. They're not the same. Each one has its own value. Every painting in the world has a different value. So that's a non-fungible token where each one has its own value. So a crypto token represents a specific amount of digital resources, either that it itself is a resources or it's created by software and it has a purpose. Questions?
Yeah, this like NFTs. So for example, you told there are some arts like which can be like sold for a huge amount of money kind of thing, right? So you mean like that is the non-fungible because the art is not like convertible or like not the same value of that money kind of thing?
Exactly.
Okay.
Yep.
So that's why we call it as non-fungible.
Or like if you have sneakers, every sneaker has a different value. So if you were selling sneakers on a blockchain, then they would have to be NFTs because each one has to be represented uniquely. You can't get a size 8 or Walmart sneakers and then a size 12 retro Jordans. They're not worth the same thing.
Got it.
Okay, so we're looking more about tokens. So tokens represent value. And when we're talking about tokens on blockchains, then they live on the blockchain. They either represent an asset or a utility. So either they represent something which somebody owns or something which is going to happen. And their rules of behavior are defined by programming, token programming. So some of the features is usability. Crypto tokens are exchangeable by nature or some other forms of same value. So you can buy and sell. You could buy a token with a cryptocurrency, or you could trade tokens. Another thing is transparency. The ownership of a token is verifiable because the blockchain ledgers are always open, public available. You can look at any transactions, and it's impossible to counterfeit it because of all the consensus and the verification and the tracking and so on and so forth. The cost and speed of exchange is designed for facilitating vast numbers of transactions instantaneously. So what are some of the mechanics of crypto tokens? They use encryption algorithms like ECC, elliptical curve encryption, public private key pairs, public key infrastructure, hashing functions, and they safeguard transaction entries. And you know who owns what based on blockchain ledger entries. The transfers can be anonymous if that's what you want to do. And digital tokens can be issued by individuals or by companies. They're purchased and traded, and the transactions are recorded on blockchain. So there's two kinds of major tokens: fungible tokens, non-fungible tokens. Fungible tokens are able to be replaced or replaced by another identical item, mutually interchangeable. I think that's a definition for Merriam-Webster. They're interchangeable with any asset or entity of the same value. But with non-fungible tokens, instead of having a value, they have data. That's the main difference. A fungible token just has data, like Bitcoin. A Bitcoin is just data on a ledger. An NFT actually has data behind the data as well. So every single NFT has to be different because the data is different. And they can't have the same value. They don't inherit any value, and each one has a unique data value. Questions?
Yeah.
There's no such thing as a bad question here, Pradeep.
Yeah, you can ask whatever question. You can ask whatever question you want.
This stuff is a steep learning curve. So
this NFT stuff just came out. It just came out. So don't worry about it. They just invented this.
Yeah. So like,
it's better to be humble and ask than to be prideful and not know. Okay.
Yeah. So like, if I hold some NFTs, like how it is like how it will be, how we can verify it is a valid one. Like I can say something like which is $100 worth or something like that, right? So how we'll be able to make sure like it is actually like $100 worth?
So the actual value of it is determined by the market. Whatever is the value of that particular NFT is determined by the market. But the value is just whatever somebody is willing to pay for it. But in terms of verifying ownership, then there's two ways. Or there's not two, there's only one way, but it's has two components to it. So the actual NFT itself will be data. So that data is either stored on a blockchain or off the blockchain. But wherever it's stored, it has metadata associated with it. That metadata is stored on the blockchain and will be necessarily assigned and associated with the actual data. So long as that metadata is on that blockchain, you will retain ownership of that data. In the same way that with a regular, like a Bitcoin blockchain, so long as on the Bitcoin blockchain, that ledger says that you have $100 of Bitcoin, nobody will be able to take that from you. So long as you keep your private key, the same thing is true of an NFT. Nobody will be able to strip that metadata, which shows that you own that data, unless they have your private key. And you always will be able to access that data if you stored it decentralized, in a decentralized fashion, but we haven't gotten there yet.
Got it.
Good?
Yeah.
Okay. So more on NFTs. Each one is unique. You can't interchange them. They're all one of a kind. So this is going into a concept called the Internet of Assets, where virtual things replicate properties of physical ones. Normally, digital assets only work within their platform or context. Do you play video games, Pradeep?
No.
Have you ever played video games?
No.
That's okay. But
Good for
I
you.
just like tried.
Good for you.
okay.
Yeah.
Do you use Facebook?
Yeah.
Okay. So you have your friends on Facebook, right? When you
Uh-huh.
go to Twitter, are your Facebook friends automatically migrated to Twitter?
Yes.
No, it shouldn't be. I don't know what kind of Twitter that you're using.
No, means like what I meant was, so when I go to Twitter, like it asks for the suggestions, right? So this contact.
Yeah, suggestions.
Yeah.
I'm trying to think of a good
Yeah.
example. Okay, here. When you log into what bank do you like to use? What's your bank? Is it
Chase Bank.
Chase Bank? Okay, you log into Chase Bank. If you made an account with Bank of America, would you expect all of your money to just show up in your Bank of America account if you didn't transfer it?
No.
You
No.
wouldn't expect that. That's because that asset is only on Chase's records. It's
Mhm.
not on Bank of America's records. The idea of NFT and digital and Internet of Assets is that your assets are not stored on Chase's records or Bank of America's records. They're stored just generally in your in a blockchain, but because you have the private key and ownership can be shown, you could be able to put them anywhere. So they're not platform specific or context specific. It's supposed to be platform context agnostic. So
Yeah.
you retain total ownership, and whatever platform you decide to use, the assets are not tied or based on a particular platform. You retain the ownership of them. That's the main idea.
Mhm.
So the main properties are uniqueness, traceability, and it can't be counterfeited, rarity and scarcity, indivisibility, and programmability. So uniqueness, each NFT has code which describes its unique properties. Each one is digitally distinct, no two are the same, and you can't copy them because each one has its own digital signatures which are unique. And it has this coded information about each individual pixel, which is basically metadata. Traceability, a record of transaction on the blockchain since that NFT was created until now. And every NFT has to have an owner, unlike files. So a file doesn't necessarily have an owner, it can just be on somebody's server. An NFT has to have an end owner. They can't be counterfeited because they have this the validation and consensus and verification process. But the creators, whoever creates it, can retain ownership in a way and even get resale rights or royalties from reselling it. So normally when people create something and they put it online, the hosting platform makes the bulk of the money. But with NFTs, it's different. It goes primarily to the person that created it because there is no central ownership. Another thing is that there's rarity and scarcity to NFTs because each one is unique. So that causes supply and demand imbalance, which is an opportunity for people to make money. And it also means it encourages developers to make their stuff in a competitive economy. Another thing is NFTs can't be divided because each one is unique. So you can't like have half of a concert ticket or cut a painting in half. Each one is just a unique item as it is. And then another thing is that they're programmable. You can have NFTs with unique behaviors, which we'll come to later, probably in the Ethereum course.
Okay.
Questions?
Yeah.
Any questions?
No questions.
Okay.
It's like good amount of knowledge.
Okay. So we have another 10 minutes. We'll see where we can get in 10 minutes.
Okay. Okay.
It's fine. We can just, so we may need one more session. It looks like we're about halfway through. So we probably just need to go through this again. Next week, we'll be doing Ethereum And hopefully by then you finished reading the document. So hopefully it will all come together in your mind. And it will be one cohesive thing.
Sure.
So kinds of NFTs. What are the different kinds of NFTs? You can trade any NFT for any other kind of NFT or for tokens, for cryptocurrencies, whatever. So some of the things that they use it for is like digital artwork, sneakers, in-game items, essays, digital collectibles, domain names, tickets, investments, collateral, coupons. I think they're going to start finding NFT solutions for like shares of companies. So if you remember a couple of months ago, they had the GameStop scandal where the brokers were not letting people sell off their shares because the brokers had control over it. So if your shares of a company was represented as an NFT, nobody else would have any input as to when you buy and sell. Digital content, there can only be one owner at a time. Unique records making ownership easily traceable. You can store unique information inside of them, obviously. You can have artist signatures and metadata, for example. Each one has a unique identifier, resale royalties, and no platform locking. So we kind of went over all that stuff already. Wallets. So I want to know how much Bitcoin or cryptocurrency or NFTs I have. How do I do that? How do I actually manipulate it and do it? Well, there's something called a wallet. A wallet is a software application. And the purpose of the software application is to do two things. Hold your keys and update the ledger by sending information to a nearby node. So what it does is you put in your public and your private key, like your username and your password. Now it knows to query the blockchain for all of the transactions with this public key and then update that, and that's your account balance. When it wants to make a change or you want to do a transaction, then it speaks to a nearby node and it lets it know, hey, I want to send or receive something. So the wallets, they track balances, they look on the ledger, they see how much do you have. And if you want to use any kind of cryptocurrency or NFT, whatever, you have to have a wallet. The wallets sign off ownership of crypto or NFTs or whatever, because since they have your public and private key stored, it can make sure that it is a legitimate transaction that the owner wants to do. So it can sign the transaction with the private key and then send it to another person's public key over the peer-to-peer network. If the public key and the private key match, then the other person's account balance will rise and yours will drop, or theirs will drop and yours will rise, depending on the transaction, the buyer or sell. And public and private keys are basically the basis of the entire network. So that's a public key infrastructure. It's a cryptographic authentication framework. There's public keys and private keys. The public key is a placeholder for transactions, basically your name or whatever. It's not going to be your name. It's going to be a whole bunch of random series of numbers. But this is how you're identified on the network as an owner. And the private key is basically your secret key that matches your public key, saved in a wallet file. It's like your bank account credentials, and it's hierarchical deterministic, just referring to the way that it relates to public keys. Questions?
Yeah. So, like using wallets. So, for example, like if I own Bitcoin, if I had purchased a Bitcoin using my like Robinhood account, and then using this wallet, like will that Bitcoin, whatever I own, will it be available in my wallet, or how this wallet is related to the account I used to buy the coins, like the Bitcoin or any other coin?
So the account, so you're talking about like a Coinbase account, for example?
Yeah. So Robinhood or the Coinbase account. So
Yeah,
for example,
so definitely don't buy Bitcoin on Robinhood because they don't actually ever give you ownership. That's like the exact opposite of the whole purpose of Bitcoin. But like a Coinbase or something. So what they do is they create a wallet for you that you never have control over. And what they do is they actually have a whole bunch of Bitcoin and then they sell it to you at slight markup. and then
Mhm.
they put it in this wallet that they're maintaining for you, and you can see the account balance. So you
Okay.
don't actually control the wallet whenever you're using one of these platforms, but they are acting as an exchange where you give them money, regular money, and then they put Bitcoin into a wallet that they're maintaining for you, and then it's there. So you can send it now. Once it's there, you can send it to somebody else's wallet. They'll do that on your behalf, or you can just put it on your own wallet. So they're like an exchange.
So that wallet like is common for any other platform like a Coinbase or any other
Yeah. So
like a Webull kind of thing.
every
They will have their own wallets.
every blockchain solution has to have some software which can update the ledger. So it may not be called a wallet, but they always have this kind of thing, which is basically a wallet.
Mhm. Mhm. But like my question is, so for example, like if I'm buying a Bitcoin in Coinbase, so you told like they will be creating a wallet, right? So uh, maybe I'm not like putting my question in the right way. So like for now, I purchased a Bitcoin using the Coinbase account. After that, I want to access this same thing in some other account like Webull or any other platform. Will it be accessible or that
Yeah,
won't be like that?
you just need to use your public and private key.
Okay.
You get your public and private key from Coinbase and you type it in and it will give you access to that wallet.
Oh, okay. Okay. Oh, but not it is not applicable for Robinhood. That's what it was.
Yeah, Robinhood actually doesn't even
Okay.
create a wallet for you. It doesn't even
Uh-huh.
actually give you any cryptocurrency. All they do is they update your Robinhood account that they
Okay.
allotted that to you. But you like
Oh,
there's no way to take your Bitcoin out of Robinhood because they never actually gave it to you.
oh,
It's only for trading
okay.
purposes. So
Okay.
it's not I really don't recommend you do that.
I can only like buy or sell in Robinhood. I'm not owning anything.
Yeah, exactly. So it's very deceptive. It's very deceptive.
Okay. Okay.
Ready?
Yeah.
So this will probably be our last one. We may have to come back to this one next time.
Uh-huh.
Storage. So there's two kinds of major storage on blockchains. There's on-chain storage and off-chain storage. On-chain
Mhm.
storage, so every blockchain has to have some kind of on-chain storage because they are a database. They're fundamentally that's what they are. They're a database. So they need to store some kind of a data. Ordinarily, the kind of data that they store is something called protocol or protocol data. So protocol data is how does the blockchain work? How do nodes talk to each other? How does transactions happen? What is the consensus algorithm? So on and so forth. But it may need to store other information if it handles dApps or NFTs. Off-chain storage. Off-chain storage you use because blockchains are not really efficient to store a lot of data because they're distributed and a lot of people need to download them and needs to be updated quickly. So if there's a lot of data on it, none of that will be possible. So what you do is you store your data elsewhere, but you let your blockchain access that data and then record on the ledger. So the blockchain handles database and ledger for data which is stored elsewhere. That would be called execution data.
Mhm.
So
But this is not owned by anybody.
it could be,
Okay.
but the two main kinds of off-chain storage which people use are IFPS and Filecoin, and those are not,
Mhm.
those are decentralized, but it could be
Okay.
centralized. So IFPS and Filecoin are just decentralized off-chain solutions. Filecoin is
Mhm.
not relevant for this project, so we won't get into it. IFPS is described in the architecture document,
Yeah.
and Flow uses that. So that's it for today. Do you have any final questions before we go out?
No. Okay. That's all I have.
Okay, so we were on slide 17. So I will, is this time good for you tomorrow, Pradeep?
Yeah.
Okay. So I will go ahead and do another one tomorrow. Hopefully we will finish up tomorrow.
Okay.
If you have any questions, you can always access me on Slack about the document, about what we went over, whatever. So we'll finish this tomorrow, get any questions fielded. Hopefully by the end of the week, you finish the document. Any questions you have, I will answer it. And then it will be time to start getting you ramped up in terms of the code, looking at what's going on with the code. By the end of the document, you should understand what we're doing. Then we have to update you with what's changed so far. And then we have to see where do we want you to go ahead and get started on. So hopefully early next week, you should be ready to start getting your development environment set up, getting your, what kind of computer do you use?
I have Mac.
You have a Mac?
MacBook.
Okay,
Yeah.
great. That's exactly what we don't want you to have. But don't worry. So there's a problem with their software. It's not compiling on M1
Okay.
Mac Silicon chips. It's fine. We have you can just do a virtual machine, obviously.
Okay.
Actually, it might not is not gonna work on a virtual machine, but you can we have cloud instances with different operating systems that you can use until we're trying to figure it out anyways, and they're gonna figure it out. So it's not a big deal. We'll get it figured out.
Dapper knows there's a problem with it. So anyway.
Yeah, they're switching to Macs anyways for development, so they have to fix it. So they're gonna fix it.
Okay. Okay.
Good.
Yeah, and also like a general question, like, can I log these hours, the training hours also, or?
Jim, he wants to know, can he log training hours?
Yes, Mark had communicated to you a certain number of hours for this, I believe. Is that correct?
No communications from Mark. So
Okay, let me double check with Mark. He was supposed to have communicated that.
Okay.
Let me find out where things are at, and I'll Slack you as soon as I hear back from him. Okay.
Yeah, sure.
Okay.
Yeah. I'm just checking, like, no concerns.
Okay. Yep.
Yeah.
Okay,
All right.
Pradeep, I had a great time. Let me know if you need
Yeah.
anything from me. Jim, do you need
Sure.
anything?
I think we're good. Great job, Ollie.
Stop
As
this recording.
usual.